Hello and welcome to an Ansys tutorial in CS 4010, the finite element analysis and structural dynamics. In this tutorial, we are going to use Ansys Fluent to simulate the water flow over few steps of a Fishladder. You're going to have your own numbers, and in here I will use my own numbers, so please do not copy my simulations. In the first step, we need to open Ansys Workspace and drag the Ansys Fluent into the workspace. So just click on this and drag into the workspace. Now you can see that the first step in simulations I need to do is I need to create geometry. So double click on geometry. Please see the signal. When it's red, that means it's running and you don't need to double click on it again or click somewhere else because it's going to turn to the waiting symbol. It may slow down your simulation a little bit. It's not really important and not necessary to double click on one model twice. Now in here in the space plane, I need to draw my geometry because my problem will be 2D. So therefore I'm going to draw an on the y and x plane. So I'm going to draw on the xy plane. So I need to change to the front view to have the xy plane. If you are from isometric, you can do the same thing by select the new sketch plane and select the xy plane. And you can draw on this now. For convenience, I've turned my view to the front view. And here will be my fish ladder. I use my line tool to start drawing. My fish ladder has a depth of 200 millimeters or 0.2 meter and the width of 800 millimeters. The elevations at each of the step will be 400 millimeters and the width at the crest is about 100 millimeters. And I repeat this for 3 steps. And here are my 3 steps of the fish ladder, 1, 2, 3. Now I need to draw the inlet and the outlet for my fish ladder. So I click on here and try to draw this one, for example, 100. And for the thickness of the flow at the crest, I assume that at the inlet it is 100 millimeters. Yeah. Now for the outlet, I draw from here 100 for the crest and then go up by 100 for example and go back and go up. And here will be the geometries of my fish ladder. I think I'm happy with this, so I just finished sketch editing. And here should be the domain. Now I just close this. In the second step, I need to create the mesh for my geometry, so I just double click on the mesh. And here is my geometry. I just use the H tool or use Ctrl E to select the inlet and then right click at it and create the name selections. You can use your own name selections, but I recommend you to use the default name. So for the inlet, please use inlet. And for the outlet, click on that, right click, click name selection and set it as outlet. You can make the name selection for the wall, but I don't see any necessary requirement for this in this one. So I can just start generate my mesh. As you can see from here, so my mesh is a little bit too coarse, so I want to change it a bit. I go to sizing and set the method, or I can go directly to the element size and enter 0.05. And then I generate the mesh again. Now you can see that my mesh is uniform and much better than it used to be. I just check the statistic to see what I have. So I have about 800 nodes and about 700 of elements. I think I'm fine with this geometry, and when I'm fine with that, you can right click and update the mesh. You can see a small notification at the bottom right over here to say that the mesh has been transferred successful, and only that you can move to the next step. Now I just close it. In the second step, I just double click on the setup. And I can select double precision to make it more precise. And I can choose the server processes I'm going to use for the simulations. To know how many processes available on your computer, please go to Device Manager and then go down to Processors. You can see how many processes you are using for your computer. If you are working on your computer at the same time, I recommend you to use only half or maybe maximum 3/4 of the number of processes. Otherwise, it will freeze your computer or slow down. For example, now I using my computer at the moment to record the video. So I just enter the number of processes as about 10 and I can start it. You can see from here, you have the geometry with the inlet from one side and the outlet from the other side. If you use a standard name for your name selections, it will automatically recognize the inlet and the outlet. If you use your own number or your own name, they will not recognize it automatically. In the selections of the simulations, if you are interested only in the final steady state of the flow, just click on steady. If you are interested in the progress of the flow, click on transient. And I have the planar problem, so therefore I don't have to choose asymmetric or other options. I need the gravity for my flow, so therefore I just click on these options and enter the gravity acceleration should be minus 9.81 because it's going down in the y directions. For the model, at the moment I have only one fluid and I want to have two of them, so I just double click on the model and turn on the multi-phase and select the multi-phase by volume of fluid. As you can see here, I have several options for that. I can choose the explicit formulation or implicit formulation. The explicit will be faster, but maybe not converged. The implicit will be slower, but will be converged. And I also want the body force as well. So I just have two Eulerian phases and I apply and close. Now, about the viscosity, I don't change any default value in this table. If you have your own model, you're free to change this to your parameters. Now, in the material, in the fluid, I have only one fluid at the moment, which is air. So I just double click on the material and try to create a new fluid. I look into the Fluent database and then I scroll down to the end of the list and try to choose the water liquid. You can see all the parameters here. For example, the density is roughly about 1 ton per cubic meter. I don't change any default one, and I just copy and then close, and then close again. Now you can see that for the fluid, I have two fluids at the moment, the water and the air. For the solid, I have aluminum, which is not quite dry because for my simulation, it should be concrete. However, I don't have the situation that the fluid penetrates through the wall, so therefore I don't need it at the moment. I can keep it as aluminum and I can change the roughness later if I really want to. Now, in the next step, I go back to the multi-phase, and then I go to phases and rename them. For the phase number 1 is air, so I rename it as air and apply. For the phase number 2, I should have is water, and I change it to water. And I apply. And then I close it. In the next step, I'm going to assign the boundary condition for my domain. So please go to boundary condition. For the first one, I'm going to inlet and try to set the inlet velocity. Because my Fishladder is very small, I set a small velocity magnitude, for example, 0.1 meter per second. And then I click on applied and close. In the inlet component, I'm click on the water and then enter the fraction of the volume of water is 1 because I have full of water at the inlet, and I apply and close it. For the outlet, I use the default pressure gauge, which is 0 Pascal because I have the free flow at the outlet. I apply and close. If you click on the wall, you can see that you can select the roughness of the wall. However, in this situation, my concrete is quite smooth in comparison with the scale of the simulation in meter. My concrete roughness may be 0.5 or 0.1 millimeter, so it should be very small, and I don't need to change it. That is why I think aluminum will not change anything for my simulations. And I just apply and close. Now I need to move to the solutions. I need to choose the right method for the simulations, and because I think all of them are fine, so I choose a simple one. After that, I'm going to initialize the domain, so I double click on initialization, and because I have two phases, so I should use hybrid initialization. I initialize it and then I patch over the volume. Please choose the water and volume fractions. Ensure that the value is 0 and apply it to the domain, which is the Ansys Fluent surface. And I patch it and I close. Now, in the next step, I need to set up the calculation activities. I auto-save the data after every 10 times step. If you want to save it every single step, it will be fine, but the problem is it will be very huge amount of time for reading and writing. So I save it every 10 times step. It should be okay to me. And I click on OK. Now I need to create some solution animation for the simulation so I can see the result. So I just double click on that. And in here, I try to make the first one should be, for example, water phase. I choose record after every 10 steps. And I create a new contour for these simulations. In here, I can choose a default, but for the contour up, I choose a phase and I choose the volume fractions of water because I'm interested in the water. I save and display, and you can see here, this will be the inlet where I have 100% of water, and the whole of the domains have air only at the beginning. I close and I click on contour 1 to save it. Now, if you open the solution animation, you will see that I have an animation named waterface in here. I may want to make another one as well, so I just double click on that and record it after every 10 seconds. In here, I'm interested in the velocity field. Yeah, and I make a new contour of the velocity. So I go back to velocity. I can compute, save and display it. So this will be the prediction at the beginning. I'm fine with that. I just close. And then I click on contour to save it. Now, if you open the solution animation, you will see the one for velocity and another for waterface. I think that's enough for me. Now I can start running calculation. Just double click on run calculation. In here, you need to choose the time step. For me, I think maybe 0.01. That means about 10 milliseconds should be okay. And I don't know how many number of time steps yet, so I just figure out a number. I can choose about 10,000, which is my favorite number, or for the demo, I just use only 1,000 only. I think I'm fine with 1,000 because it will just going to drop in here, and then you can keep continuing with your own number. It takes me only 10 minutes for that. So now I can start calculation. And here is a conversion chart of the simulations. I think it will take a bit time. It takes 1% in about 3 seconds. I don't know how much. So just let it run and see you in a few minutes. All right, now, so after 11 minutes of calculations, I already reached the end of 1,000 time steps. As I can see over here, if I'm looking at the playback and I'm choosing the waterface. So at the end, I just fully fill only half of the first step in my Fishladder. So therefore, I think I may need about 10,000 steps, and I may need about few hours to run the simulations. In this simulation, I choose my initial velocity is really small, which is 0.1 meter per second. If you have it about 0.2, you will double the filling process, or if you have 0.5, you will make it 5 times faster. However, when it will make it too fast, for example, 1 or 2 meters per second, the flow may go over the step and do not fully fill the water over here because it works like a Z, go from the inlet directly to the outlet. When you try to export your simulations, you can use the screen recording and just play this one. You can see how it fully fills on the top, or you can choose to write it into a video file and click on write. I hope this tutorial can help you to do the simulation for your own Fishladder. Thank you very much and see you next time.